So this is going to be a quick demonstration of the FullRank hypothesis prospecting tool. The tool allows one to, given a problem, in this case, is trying to find from a data set the sale price of a specific property. Given that data set, try to reduce the error as much as possible. And to do this, one builds a tree of hypotheses that, taken together, are a ensemble model that hopes to reduce the error as much as possible. So the first node in the tree is typically the average value of the homes in the area. And so if we look here, we can see that so the average price is about 180K in this data set, and this is the sort of error distribution around that. So while this is the expected value, we can see that it's an asymmetric sort of error around that. In this specific house, you can see the qualities of the house here. There was an error of 100%. So the estimate was 180K and the actual was actually 85K. And so we can see the difference is this. And that's not unexpected because obviously we're just guessing the average price. But let's try to improve upon that. So first of all, we look at our data set here. And one of the fields that comes to mind when we think of housing is location. And so if we look at the location field in the data set, we can see all the different values here in terms of the names of the neighborhoods and also the counts of each of these. The tooling also provides with some annotations, so you can annotate the different fields and values, which comes in handy when you have kind of abbreviations and so forth. So we can see if so this is the sort of count versus the different discrete values in this field. But let's just quickly to try to see if there is some sort of a relationship between the sale price and the neighborhood. We typically pick the residual. We can pick the sale price, but the residual is basically the current guess, in this case the average value, minus the actuals. So let's take the sale price first. And we can see here that generally there is a trend. We see that this vertical bar is the average, and so for each of these different neighborhoods, we see that it definitely appears that there is the sale price varies with the neighborhood. So we should find the same relationship if we look at the residual. So look at the residual here, and again, that's just sort of shifted by the constant value. So if we look here, this is centered around the average price, and this is centered around 0, which is what we expect. So we like to add that to our tree, and so we're going to pick the residual, and we're going to create a hypothesis around that. And creating that hypothesis, we see here these are the different hypotheses that are generated. We see here that it seems like, if you look at the differences, it seems like it does a little bit better than average. And here are the details for each of the different attributes of the hypothesis. The difference, certainly, this is the actuals. This is what the hypothesis predicts, and this is the difference between the two. And it seems like that should reduce the error. So let's add that to the tree. So we look up here. It's going to add this to the current selected node. So if we look on this node, we see that while the error was 50 on average, 57,000, by adding this, by adding the hypothesis and taking that into account, we see that the error is now about 38. So it was a substantial improvement. So if we look at a random house, so this is just testing the different. This is testing the current selected hypothesis. If we see, if we try to get the results, we can see here that it will return a reasonable response. If we get another random house, and do it again, we find that it's the estimated is 135K, and the actual is 158K, and it's reasonable error, but we'd like to reduce that. And so we look at we take this into the second one into account, building our tree there, and so we might say to ourselves, well, maybe the greater living area, so the square footage of the house, maybe that matters. And so this is a continuous variable. So let's look at a scatter plot. So if we look at a scatter plot versus the residual, right? And we color it by this is just again coloring the actual plot. So if we look at let's see the garage type for no good reason, and we graph that, we see that it seems like there is a relationship. It seems like it's kind of sort of a linear relationship going up and to the right. And so we expect that if we take this into account by adding a hypothesis for this field, then we should reduce our error. So let's try that. So we will again select the residual. We will select a polynomial of a decent degree. Again, setting some of the hyperparameters, and we will generate the hypothesis. It can take a while, depending on the size of your data set and a bunch of other factors. It can take up to several minutes to create a set of hypotheses, but typically it's not too long. It'll show up here in a second. Okay, so it's showing up. So we see there's many different versions with varying errors. So if we look at the visualization here, so we see here that the algorithm generally did pick up some variation, and we can kind of see it here visually. And so the blue is the actuals, the estimates of the red, and then if you subtract from one from the other, you get this residual here. And we can see here that if versus this original blue line, we see that it's reduced the error somewhat. And so we expect that that's going to again reduce the error. So let's add that to our current tree. So by adding that to the current tree, again, the error is reduced again somewhat from the previous node in the tree, but not as much as the previous step. So this is again something that we see commonly in that as you account for more attributes, there are some sort of overlap between the attributes, and some are better than others. And so we generally see that this reduction error is reduced every time we kind of account for a different type of variable. Let's get the results with those two things taken into account, and we can see that it's getting better predictions as we sort of go along. So for each random observation, we get the results, and again, it seems to be a little bit sharper and a bit more refined in terms of the results. We can also visualize the itemized aspects, and so we see here that here's the average. So again, our first guess is the average, and so it's 180K. Our second guess is around, as we've discussed before, around the neighborhood. Seemingly, this neighborhood is below average in terms of the evaluation. And then we look at the given these two preceding items, we see that even taking into account this neighborhood, this home is slightly smaller than average, and we see that that again subtracts from the value of the home. And so, you can imagine a very complex series of these, and indeed, with the sort of auto ML tooling that we'll discuss in another video, there can be 30 plus different attributes to an ensemble, and that gives us a very fine result indeed. But as I said before, it is a tree, and so you can build out multiple nodes. So let's suppose instead of following this line, we said, well, we're maybe interested in, let's say zoning. So maybe zoning has some bearing on the sale price. So let's create a scatter plot just to see if that's the case, and seemingly it does. Seemingly there is some variation, and seemingly the sale price does vary given some zoning. So let's again create a hypothesis. Let's change this hyperparameter. And we create that, and if we change this, we see again, these are the different hypotheses that were generated. We can see a diversity in the error rates, and how much error the output was reduced by. And so these are the actuals again. This is the hypothesis response. This is the difference. So we see that seemingly the actuals and the difference, it seems like the difference does reduce the overall error. Here's the details, just some details of the hypothesis that was generated. Let's add to that to the tree, and so we see that this node was added kind of in parallel with, in this case, the neighborhood. And it's reduced the error, again, somewhat, but certainly not as much as the neighborhood. And so we can, again, keep iterating in this fashion and build up some interesting hypotheses. Obviously, there is tooling, as I mentioned, that allows one to build out more complex hypotheses in an automated fashion, but that's a subject of another video. Again, this has been the FullRank hypothesis prospecting tool. Thank you for watching.